going to talk about is MCP on the edge. So before we start, I just need to give you a thought. Like most of the team out here must have been fed with the belief like having three things in parallel, specifically for the agentic system, is not at all feasible. I'm referring to a system being capable, compliant, as well as offline resilient. But what I understood, like these are not in conflict, but they go hand in hand. And in this forthcoming slide, I'm going to challenge this argument. And what I ascertain that this is something feasible, all these three aspects with a single architecture level decision at a one time. So herein I'm bringing in EdgeMind. EdgeMind is the name we have given. This is basically a protocol that's using a frontier class model language along with the MCP plane that decides that we are going to run the inference on the device, sending no data across to the cloud and no token cost. So basically we are proclaiming like there will be zero token cost when we are going for implementing MCP as a protocol for the edge devices. Hi, this is Akhil Gupta, and this is the prototype I'm going to present. But before that, let me show you a quick demo. If the time permits, I'll try to do that live as well.
Internet connectivity. What does it mean?
So I think it's not shading on this. Okay. Okay, maybe I'll do it practically at the last. I had a recording for the same, but at the end we'll see if we can do that live. But I'll like to proceed with this here. Yeah, so we define that policy is a protocol. So what do we mean? Before we get into the solution, we need to understand what problem we are trying to address out here. So basically, when we talk about data privacy and the regulation, these are the terms that is something not a luxury. It's not something good to have in any system. It's an obligation. Now, India's DPDP Act is already in force, and the GDPR Act, as you know, it's about a decade old now and has enforcement needs. And moreover, if we are from the domain that specifically be it a healthcare or the financial, we have their own domain-specific mandates on top of the stack. So what I'm trying to say, like data governance or data privacy is not something only to keep your data safe, but it's rather to ensure it doesn't leave the jurisdiction. Along with, we have proper way to monitor or do the auditing of the autonomous decision being taken by the system. Now, before we deep dive further, I just want to walk through how the standard we are being following it for the AI system as of now. So generally, we see for AI systems, user writes a prompt, it gets serialized and being sent over to the cloud endpoint, and we don't know where it actually go. Why I'm saying so, it's the auditability turns out to be a challenge here. And we need to ensure that what action has been done in past, that turns out to be a big liability for the current architecture. So now if you think about the use cases, think about a ward nurse performing an operation in the basement, or there is a person who is working in oil refinery with no signal or no Wi-Fi connection, and be it a defense system where they don't have luxury to do a TCP handshake. What I mean, they don't have a privilege to send the data over the network. And even if they do, that doesn't turn out to be just a technical glitch. That's more like a compliance breach. Means we don't have a provision to send data across the network. Yeah, and we'll talk about the high-level 3 points out here, like what is the cost associated with this architecture, other than the audibility. The very first thing, whenever we are sending the data across the network, we are getting charged for the tokens. That's something we can easily measure. Then we have the cloud round-trip latency, that's also measurable. But what breaks the system, whenever our system is on the network that cannot be trusted. And also in the cases that I just talked about, the defense system sending data across to the network is something, it's a compliance breach actually, it's not just a technical flaw. So how do we attain that our system is able to retain the data as well as it's resilient? So what we are presenting here, like we can attain the same by defining an MCP plane. So generally we think about MCP as a tooling. So what I say, MCP is not just a tooling for the devices, but it's something like can we think of as a protocol a protocol with a single choke point that will define which all AI models we can use and what should be the permission given to the tools that are being called by the agents, and eventually how the governance is being implemented. Everything to be done locally in the device itself without any data leaving the premises. So premises here I am referring to the device. It should not be, data should not be touching out in the air. So there's no data being sent outside the device. So all these things should be done in a one flow. So if you see in the slide here, there's a pipeline defined. So very first time we'll have a UI layer which creates the payload. Payload being sent to the MCP client. The MCP client will be having the token, will be having JWT token, but that's a scope based for the agents. And eventually it's being sent to the MCP server. It looks like a standard pipeline, but the crux is we are not sending it over the network. The data being sent to the MCP server as a coroutine, or you can say a local method call. And eventually the inference as well is being done locally. So if I say in line, it's like in a MCP, we are retaining the protocol, but we are deleting the network. We are killing the prerequisite of having a network for MCP implementation. So if you look at the pipeline, starting from the security layer, we have guardrails defined. Then we'll have IAM service. Then we'll be having the governance defined by the confidence score that we get for the models we have implemented for triaging the input prompt, and eventually the inference. Everything is being done within the system and not sending any data. So there's no ingress outside, means you can think of if you are not able to send any data outside, so there's no question of a data breach. So good enough, like we are able to put everything in the device, but what do we attain? As I just said in the beginning, we are going to attain the compliance as well as the capability. So how do we attain the two? If you see the left side, we have the capability hub. So what do we proclaim here? Like we have a lot of models, considering a case of I3. That is something can be easily used as a SLM and can be quantized to put into the device as well. It's so good, like we can quantize it to fit into in a mobile phone itself. And when we are able to quantize this and put into the mobile, means we are not sending using any API key, we are not sending any token outside. So zero costing for sending the tokens. The right side says we are attaining the compliance. So compliance, how we are attaining it by default is because we are giving a provision of, we are ensuring rather that we are not sending any data outside, so we don't need to bother about the boundaries. Like it should not be breaching the boundaries. We are not sending any data outside, so the data privacy laws are already being taken care of. Yeah. Yeah, so that's the reason I have entitled the slide, this deck as policy is the protocol, because going further, data privacy laws, it's something should not be a part of the policy document, but would be the architectural decision taken when we are building the system itself. And by default, it's giving you that your system is compliant with the GDPR Act. And it's no more a policy, it's rather implementation at architecture level. So now the next thing comes in picture, how do we ensure that we get all these things, the governance, the security, as well as the auditability at a single place? That's the MCP plane. I'm going to explain the next forthcoming slides. But prior to that, I need to spend a few minutes to walk you through what exactly made it feasible. So as we understand ExecuTorch. ExecuTorch is a lightweight runtime inference engine that makes feasible to deploy the AI models on the edge devices, or we can say any memory constrained devices. And that is the sole reason or a novelty for this particular prototype that ensures that we are able to jolt all the points together and develop the whole complete pipeline that could be deployed in the phone itself. So here we see, so here we are able to see the four major cards that explaining what is the novelty that ExecuTorch is bringing in. The very first thing is, the ExecuTorch comes with the native support for the model export, for the PyTorch model specifically. What does it mean? The computational graph that's get generated for the models can be directly mapped to the backend accelerators without any different runtime engine. We don't need a runtime Python as well on the phone. And above all, like whichever model we want to use, be it Phi3 or Whisper, we just need to have one .pt file. That's the artifact that would be run on the inference engine. So that's the only prerequisite there. Secondly, it comes like we are able to quantize the model using the int4 format, along with giving a compile time static memory allocation. So what does that ensure is that as Phi3 model, if we talk about, it could be easily quantized to as good a size of 2 GB that could be fit into the phone. Along with that, we are able to ensure that at the runtime, at the inference runtime, we won't be having any stalls because of the garbage collector being running there, because we have a provision to define the static memory allocation itself. The third point is like the backend accelerator. If we talk about, it's a Qualcomm STP for which there is a direct support for the execute torch, because it directly lower it to, that is the graph that is compatible with the Qualcomm backend. And even if we go with any fallback mechanism instead of the STP processor, we can simply leverage the same .pt file. And the fourth and very important one that makes the difference is like execute torch comes with the API for training the model as well. The point is like irrespective of any model we are using, we are able to train the model using the QLoRa rank 8 fine grade training model. And we are able to use the same dot file that's already being loaded into the inference engine. The point is like for training as well as for inferencing, we can use the same inference engine. And another thing is there won't be any data sent outside even for the federated training. So that again justifies that there won't be any privacy liability because we are not sending any data across to the network. And just to reiterate this thing, like even if you talk about any other mobile runtime engine, specifically from Microsoft, we have ONX runtime. None of those are today giving compatibility in terms of all these four aspects, be it direct native export for the models, or is it quantization, or is it something to do with the compatibility with the backend accelerator, or training for the model on the phone itself or the device itself. So the core idea here is to define a control plane wherein I'll just reiterate the same thing that we'll be retaining the protocol. MCP is being used here as an orchestrator, but we are deleting the server. We are just breaking the ties between the server and the server over the cloud. So everything is being done on the device. Well, so now we'll see how do we implement it. If we segregate this ask into the two parts. So first is security layer, second is the governance. So for security, we can visualize we have implemented the two gates. The very first one just simply talks about whether the prompt that we are getting, is it valid one or no. In case if it's not, the process will not be happening, and we'll be saving that using the SHA-26 hashing. So this is something apart that comes with auditability. And the gate 2, suppose the gate 1 passes, gate 2 will answer a different question. That's an IAM service that look for whether the prompt that is being sent to the system, is the agent liable, is the agent having the authority to call that further. Basically, we are checking for the scope. We need to ensure that the agent should not be in the scope, even if the content being asked is a valid one. So how we have implemented the scope is basically at the runtime, whenever session is being created for the agents, we are defining that role. So the default role is for reading the SLM and the knowledge base, and the elevated one is for the LLM, and eventually the system level is for accessing the phone accessories like, for example, the mic or the associated accessories. So the right side we see the governance. Now that's a critical part, how we are deciding for a user prompt which actually backend should be called. So this is solely defined by the confidence level that we are getting from the model. So the flow goes like the very first time we'll be making a call. Most of the time, the ballpark number is 80% of the time the SLM will be called. And if it's giving us the response based on the distribution to be above the threshold we have defined, we are good enough to send it back to the user, else it will be augmented using the RAG. We are using here the FIS indexing. Even despite that, if it's not reaching the threshold, last resort would be to go for the quantized large language models. Yeah, so this is something not only on the demo or only on the paper, this has a proven, production proven. Like if you see lately, the there's the integration happened for the Meta with the Raven glasses. That's itself using ExecuTorch as the inference engine. On the slide, you can see we have a certain other example as well. Specifically, the Qualcomm, if you see, this is the implementation we are trying for the EdgeMind as well. So next thing is we need to understand like this is not something confined to any domain. Why we call it not a project but a platform? Primarily because this is domain agnostic. The system or the demo that we are going to see is something, don't know anything about the domain, the clinical domain. So what does it mean? Like whoever want to implement, want to ship a different vertical, he just need to swap the 3 files. Primarily the corpus, that's the domain knowledge you have trained your model on. Then the indexing, and eventually the .pt file. So .pt file is something, the model file that will be run against the inference engine. And what stays identical, starting from the MCP orchestration to the security stack, the inference runtime or the federated loop, means the training the model. Everything will remain intact. So you bring us just these 3 files, rest pipeline will remain intact. So if you see, we have extrapolated this one for 6 different verticals, starting from logistic to pharma to emergency or for customer experience. Down in the slide, you can see Salesforce Einstein already has proven this one. This is from their official documentation we can see. And similarly, for the logistic, we can see a very potential use case of using this, where we can save a hell lot of money by not sending the request to the cloud, but rather using in the device itself. The thing is, for most of these companies, we'll have seldom change of the data, proprietary data. So it's always preferable to go for the edge inferencing rather than making call for the cloud. So there are certain things that which are working as of today you see on the slide and certain restriction. Since this is a prototype, we have certain engineering gaps as of now, but this is not a blocker. This is something can be hardened with the time. And this is the last slide where you can, if interested, you can have take this QR code to us, and I'll be happy to get in touch with you guys. Actually, I need to show a demo out here. Actually, I'm seeking some assistance from the management side for setting up the system for the demo. Okay. Can I have someone on the stage, please? I need to set up this phone for the demo, please. Yeah, I will recorded demo. Either you can start to share the screen, my YouTube channel screen here, or either we can connect to the phone for the live demo.
Actually, I'm from the audio team. I'll check with the screen.
Yeah. Just bear with me for a minute. I will just setting up it. Can you share that screen? Actually, I want to show my YouTube link. Actually, there's a recorded demo. It's not getting mirrored. On the screen.
This you'll have to.
Is the recorded image?
You'll have to.
Yeah. So,
Now you can.
the audio will also come. Yeah.
Things we are going to use.
Shall I put the mic in front of the guys?
No. one of these. You'll have to play it and you'll have to play the audio. No, not this one.
Just switch to the other one. I'll put the mic here.
Switch to the other one. And just click over there. Yeah.
Okay, this won't be that helpful actually. You're not able to set up the sound properly. Okay, I'll play this with the mute actually. Yeah. So this is the device that this is the app that we have installed on the phone by EdgeMind. This is completely an APK file defined on the phone. And here it shows a demo, like how we can visualize like the triaging being done using the MCP. The very first one, if you see, we are getting response from SLM based on the confidence level of 0.9. It's a bit difficult prompt to understand. It goes directly to the LLM. And the third one for triaging, it's something, it goes from the RAG. So it's basically we are doing inference from the 3 different backends based on the complexity of the prompt being asked by the user. So the core idea here is like, presently though we are doing for AI inference, but AI governance on the edge device is the future actually. We need to ensure that we have the data being governed, not only being saved. So we need to define the boundaries, and we are leveraging MCP orchestrator to define the same. So this is what I had today. So I appreciate you all time out here today. Thank you.